hello there, everybody. My name is Johan Thestrup, and I will be presenting to you my tech talk, Testing 1, 2, 3, a beginner's guide to test-driven development and behavioral-driven development. So who am I? Well, my name you already know, but I grew up in Sweden playing a lot of tennis. Later on, I went to university and got myself a bachelor's degree in music production. And I recently started coding, and it's at this point it seems as though I cannot stop coding. So I believe the red thread between these three seemingly very different fields is that I'm very interested in systems and how certain systems have the ability to yield a desired outcome. So in music, what usually interests me are patterns, both simple and also complex. In tennis, I'm also fascinated by patterns. The tennis player's execution of these patterns are mostly unconscious, but it's certainly a lot about recognizing patterns. And so, of course, getting myself into programming, I find myself searching for the pattern that will give me or my team the desired outcome. So the idea that test-driven development proposes that you might be able to have an automated test suite that would tell you that your app is able to deploy really speaks to me. Is that possible, though? At what cost can one develop such a test suite? And is it worth it, and so on? These are some of the questions that we will explore in this talk. So how is this talk set up? Well, we're going to start off with a short history lesson. We're going to jump into the philosophy of TDD, also some BDD. We're going to learn how to write a test. We're going to discover that there are different types of tests. We're going to talk about some pros and cons. And lastly, we're going to end with a short discussion. So let's jump into the history. So testing can be quite a charged thing to talk about, and there certainly is a lot of different opinions circulating this practice. And some might even argue that some people find the test a little bit scary. And this is particularly interesting because the person attributed with coming up with TDD writes that TDD is a way of managing fear during programming. And the person who came up with it, he's on the screen right now. His name is Kent Beck with the lovely tie-dye shirt. And TDD came about when he was working at Chrysler through an ethos called extreme programming in the late 90s. Kent has written plenty of books on TDD, and he's still active in the community, and you can find him discussing TDD amongst other things on YouTube if you're interested. And other burning questions on everyone's mind. Why tests? Why did someone come up with tests in the first place? Let me kick off this talk by talking about, so the reason for tests obviously is that no one likes malfunctioning software. So let me talk about some of the most terrible bugs in the history of software. We have the Ariane 5, which was a rocket ship that crashed shortly after it was launched. The cause of this bug was that the system was trying to convert an integer, a 64-bit integer into a 16-bit one. The estimated cost for this was $500 million. Second, we have the Knight Capital, which I believe was a stock market software. The cause of this bug was that the code was mistaken a production environment for a testing environment. The estimated cost for this was $460 million. And lastly, but definitely not least, we have the Therac 25, which is a radiation machine used for treating cancer patients. The cause of this bug was that the UI was displaying the wrong mode to the doctor, which caused the doctor to overexpose their patients to radiation. And 4 people died as a consequence of this bug. So could a test-driven development have changed the outcomes in these cases? Possibly, I don't know. I guess no one knows. But in any case, it teaches us that humans are humans and that we might not always be the best judges of whether our code is working or not. So for the main player for this talk, let me introduce TDD, test-driven development. What is it? And what's the philosophy around TDD? So as I've already mentioned, a lot of strong opinions circulating in this practice. We have our fundamentalists, we have our moderate believers, and we also have the deniers. And everyone believes very strongly here. So the first rule of TDD, we write our tests first. The second rule of TDD is that we write our tests first. And what do I mean by this? You can take it quite literally. We visit our tests before we write our production code. This is the philosophy of test first, which is a part of TDD. Second, we have the red-green refactor. What does this mean? Red means that we write a failing test, preferably a very small one. We then move on to green, in which we write the simplest possible code to make the test we just wrote pass. And then we have the refactor part, where we examine our code, we test for more cases, and then we repeat this cycle over and over again until we have our software working and running like we want to. So let me ask all of my friends here, do you jump straight to the code examples when you read documentation? 3, 2, 1. Everyone reads code, right? If you're a developer, we read code, not text. So imagine being new at a job with a huge code base. You are now asked to implement some additional functionalities. At this point, you are not very familiar with how the code works, and you feel as though you might break something if you were to start coding. Not a very productive mind space to be in, right? But now your working buddy tells you that you can be sure that you won't break any functionalities as long as all the tests are passing, because they have a well-maintained test suite. Phew, what a relief. Well, TDD, if followed with disciplines, promises that you will be able to produce such a test suite. All right. Next section, how to write a test. Of course, we need to answer this question too. What is a test? So in the very center of my screen here, you see a test. It's almost written in plain English. Like if I were to read this out loud to you, I think you will be able to understand what this test is doing. Describe my calculator. It should add 2 numbers together. We're skipping this a little confusing row here and move on to expect sum to equal 3. All right, this is how you can how a test might look like, or what a test might look like. There's also something called the SEAT method, which helps us structure our tests. S stands for setup, E stands for exercise, A stands for assert, and lastly, T stands for teardown. So here is a demonstration of SEAT. We do our setup, we create a new cat, we do our exercise, we call the method meow on our cat, then we expect sound to equal meow. This is our assert part of SEAT. And lastly, very sad part, we tear everything down. We delete our cat. All right. So this is pretty cool, right? But how do we know what to write in the first place? So far we know we just test functions. We don't know what to write in the first place if we just follow this. So this is why we introduced BDD. So BDD came about as a necessary extension to TDD. TDD is not unsurprisingly always welcomed with open arms. After all, a company gets paid for production code and not tests. The value proposal and the promised payoff of TDD is not so obvious to everyone. So if you're not sold on TDD, perhaps you'll enjoy the extension of TDD called BDD. So let's say you are developing software for a client. A good thing to figure out is, what do we want our software to do? We start with the big picture and we gradually drill further and further down until we can describe user experiences and behaviors in our app. A little underline on behaviors here. In BDD, we call this pattern given, when, then. Let's make a given, when, then example together. The app we are developing has a to-do list. BDD uses easy to understand language and invites non-technical people's language to be used to describe the behavior. So we can say, given that I've added text in the input, when I click on add, then the text is added to my to-do list. All right. I'm sure you can see how one can create loads of these user stories. BDD focuses on the application from the user's perspective, and it tests for how the user interacts with your application. And it's ultimately a philosophically different approach than what TDD originally was. So let's create a cat. So I've copied over our given when then over here. This is what we will create using the TDD practice, or BDD. Given that there is a cat, when I pet the cat, then the cat purrs. All right. So like we talked about, the first rule of TDD is that we start writing the tests. And I've already cheated a little bit here. As you can see, there's already some code written here. So we have our setup. We are creating a cat, and we are asserting that Gimli actually is a cat. Okay. So let's run our test once here. And we are green. This is not good. This is not good. We need to turn it red. Okay. So let's exercise. Let's see here, we say sound, and then we say purr. And now we have a test, but we need to assert it too. So let's expect sound to equal, let's see here, boom. And now let's all hope that we get red. This should not pass. Okay, so this is the cool thing about BDD or TDD here, is that the error, if you read it with me, gimli.purr is not a function. It tells us that something is wrong, and it also points to where the code might be wrong. So let's jump into our code here, where we only have a cat right now, but we can see that we do not have a function called purr. Let's create that. And let's run our code again. Okay, we're still red, but we have a different error. Now it says expected undefined to equal purr. What might be wrong? Let's see what happens if we return purr from the function. Run the test again, and we are green. Wonderful, wonderful. So this is a very simple example of how one could practice TDD. So if you remember, we have the red, green, and then we have refactor. So this is the point where we will go back to our tests and write further testing and keep going like this, the rhythm of TDD. Red, green, refactor, red, green, refactor. Okay, let's jump. Oh, what a cat. Next section is called different tests. What we just wrote was called a unit test. We tested a single unit. Unit tests are very fast and are generally considered the easiest to write. Having many unit tests can assure you that your individual functions are doing what they are intended to do in isolation. Unit tests do not test for integration, but we do end up with a great documentation of what our units are intended to do at the time of writing them, which is really nice. Also, we have a really fast test suite that we can run every time we hit save in our project so that we get alerted as soon as something breaks. So, unit tests. Next one is integration tests. Integration tests are testing how our units interact with each other. So if you look at this picture here, we have a module A, module B, and module C. All of these modules do something individually, but they also have a point at which they interconnect, where their behavior together is important for our program to run. So integration tests, for example, might test how your shopping cart calculates the amount that later will be inserted into your payment service. There's many funny names for integration testing. Amongst them are Big Bang and Sandwich, which are methods of which you can practice integration testing. Then we have end-to-end tests. End-to-end tests for example, you have your customer visiting your web page first. The customer gets interested in a product and checks out the product and completes a payment. So an end-to-end, start to finish, you can think of it like this. So let me give you an example of what an end-to-end test might look like. Your customer visits your homepage, looks through your products, picks a product, adds the product to your shopping cart, chooses to pay by credit. it will get very tedious to click through this end-to-end test manually every time you change your code. So this is where an automated end-to-end test can come in really handy. Of course, all right. So, but now you're thinking like, oh, end-to-end test sounds like super, super cool, right? It tests exactly what our user wants to do in our software, right? But end-to-end tests are super duper slow. And there are examples of test suites that takes over an hour to run. And you can imagine how often those tests get run and how the test suite ultimately is completely useless. Set that in contrast to an arbitrary rule that's circling around the community that says that all your tests should run in less than 300 milliseconds. Quite a difference there. So we've spoken about unit tests, integration tests, and end-to-end tests. In the picture here, it says UI test, but I want you to read it as end-to-end tests. So this is kind of a balance you might want to shoot for. And they basically ordered in terms of the speed at which the tests are running. Unit tests being the fastest and the ones that you can write pretty much without any extra thought to how slow or fast they are. After that, we have integration tests, and then we have end-to-end tests. All right. So let's get into some pros and cons of TDD. Because up until this point, we have mostly talked about the positive effects of test-driven development. But what are some downsides and common critiques of working this way? Because the truth of the matter is that most software was developed without using test-driven development. And if you only heard the positives, you might wonder, why? Why would you want to miss out on all these wonderful promises of test-driven development? Well, I will present to you some common critiques. The first one, and perhaps the most obvious critique, is, and it really strikes the core of what TDD is why tests first? And why test something that will never break? The TDD advocate will answer that writing tests first forces you to think for a while extra before your implementation, and that even if the test won't break, the test might serve as documentations further down the road, like a roadmap to the developer's mind at the time that he or she wrote them. A more subtle critique, and one that you really have to think about, is that it is the developers themselves that write the tests in TDD. So if the developers can spot the case that breaks the application, then how could she have written a test for it in the first place? The last piece of critique I like to bring up is that some developers simply doesn't enjoy practicing TDD. The inventor of TDD, Kent Beck, talks about him enjoying the rhythm of TDD, the red-green refactor rhythm, which we had a brief encounter with earlier in our demo. And it seems to be a common thread for people who enjoy practicing TDD. It is about the rhythm of red-green refactor, and out of that springs all these magical positive side effects. And naturally, everyone doesn't enjoy that rhythm, red-green refactor, red-green refactor. So let's jump into our discussion. So if you watched my talk and thought that it's about the discussion about TDD or not to TDD is about tests or no tests, you are wrong. The majority of the community agrees that tests are good. It's rather a question about what extent they are good and in what order they should be produced. Because most software was not developed using TDD, there are not that much data on the actual effectiveness of the practice. Needless to say, though, that the TDD believers do really believe strongly, and the little data that I managed to gather show that there are benefits to this practice. And TDD believers would describe the reason that you might feel hesitant to even start looking at TDD as an option for your next project is because of this graph right here. So the blue line demonstrates the number of features you're able to produce over a certain amount of time. So it says that in the very start of your application, using a traditional approach, it absolutely crushes the amount of features you're able to produce from the beginning with TDD. But as you can see, over time, TDD becomes faster because you have this strong test suite that you always can reference if you're unsure if something will break or not break, and also the wonderful documentation that the test suite might serve as for some people. Next, I found this semi-scientific article on Medium that that asked developers if they practice TDD, and if so, what do they think about it? And you see the blue part of this circle here, roughly 40% says that I actually like it and benefit greatly from me writing them. And we have the gray part, which is more like 50%, that says that I don't like it, but I understand the value of me writing them. And then we have the black part here that says that I hate it. I don't write tests. It shouldn't be within the responsibilities of the developers. All right. So what about me personally and TDD? Well, personally, I'm excited to give TDD a go on a bigger personal project and explore the pros and cons myself. And I hope that my talk has inspired you to go out there and form your own opinion about TDD as well. All right, thank you very much for listening. And yes, you are able to find me on the same handle on all these social medias listed below. Thank you very much.